Authorizations allow administrators to configure the level of access a user has to one or multiple objects or an object type. A typical example of this is a designer who can edit a job but cannot execute it on a production client. Authorizations require a bit more configuration than privileges because the feature is quite granular. The model is streamlined but remains quite powerful. Overall, there's a high level of configurability to authorizations. Authorizations define action permissions on objects, named either generically with types and wildcard symbols or explicitly with names. Possible actions are read, write, execute, delete, cancel an execution, access to a task's execution history, open a task report, and modify a task at runtime. If you check a box, the user can perform the action, otherwise it can't. By combining objects and actions in several groups, we can design sophisticated systems of permissions. Let's consider some of the methods for designing authorizations. The first is the name of the objects and uses the name field. This is a straightforward naming system with wildcards, star, and question mark. Star represents any character string and the question mark does a one-to-one character substitution. Object types can also be used. You might want to give a user the ability to do anything on individual objects and file transfers, but remove the ability to execute all workflows because they might impact other areas of operations. You can create multiple lines and the group numbers determine the behaviors. Each line can contain specific sets of authorizations on different objects. Lines that have the same group number are inclusive to fine-tune access. They're compounded. If you add a group 1 with read enabled on jobs and another group 1 with read denied on jobs, then the enabled takes precedence because they're the same group. Lines with different group numbers are exclusive. Automic automation considers the most restrictive setting, which supersedes settings for the other groups. The not option reverses the effect of the authorization setting. Let's consider some examples. Keep in mind that possible permutations are endless, and these are by no means exhaustive. We recommend testing each configuration before applying it to a production environment. In the first example, we have a single line that applies to all object types and names in which all authorizations are enabled. We have removed the execute authorization so no object can be executed. In the second example, both lines are group 1, so any restriction defined in the second line is irrelevant. The user has all rights to all objects. The third example states that the user can perform all actions on all objects. The second group is a not statement, meaning the two groups intersect. The not removes the ability to view login objects, so the user won't be able to open them. However, login objects can still be used in executable objects like jobs and workflows. They can even be changed. Finally, in the last example, we have two groups. Group 1 allows everything, while Group 2 takes precedence and allows nothing. The user cannot do or even see anything because it doesn't have a read permission on folders. Use caution when implementing authorizations and do quite a bit of testing before implementing. There are some minimum requirements if you don't want to incapacitate your users. There's a read requirement on folders. Without it, users won't be able to see anything except for the Explorer folder items like transport case. For users to execute objects, they need more than the authorization because these objects are compounds and need quite a bit. Execute authorizations are required on host groups, login objects, queues, and calendars. If you deny all actions on all objects, you effectively remove the process assembly perspective. Finally, to edit a job, you will need execute authorizations on these three include objects generically. We've set up two instances of AWI. At the top we're in client 0, and we're editing authorizations for user 123. At the bottom we're logged in as user 123. Assuming the right privileges, the user can do anything, including execute objects. The object executes without any problem. Let's remove the execute authorization and log the user out and back in. We now have an access denied. The object won't execute, which is confirmed in multiple places, like messages and the process monitoring perspective. We can try restricting write permissions on login objects. The login object can be edited without any issues. The login object is now read-only.